All right, we're good to go, Greta. Oh, see, yeah, this is the funness that you can be having in algebra too. Okay. All right, so we started talking about sequences and series on Monday, and I think that was not too bad, right? Wasn't too bad. And we talked a little bit, so we just talked about generally what is a sequence, what is an infinite sequence, that's one that goes on forever. What is yeah, pretty easy. What is a finite sequence? That's one that has a certain set of terms. We reviewed what a factorial was and what summation notation is. Okay. So today we're just going to focus on one set of sequences, which is arithmetic sequences. So the idea between this is that if you have a sequence of numbers, I'll make this a little bigger. There we go. We have a sequence of numbers, then the difference between every number is going to be the same. So in this case, number 1, excuse me, is an arithmetic sequence, right? The common difference between each of these, it goes from 10 to 8 to 6 to 4 to 2, is -2. So the common difference is basically the second term minus the first term, or the third minus the second, or the fourth minus the third. So you're going to subtract those two and see if you have a common difference. So that's the definition of an arithmetic sequence. Let's just do a couple of these really fast. So number 2, the difference between the second term and the first term is 9 minus 4, which is 5. The difference between the third and the second is 14 minus 9, which is 5. The difference between the fourth and the third is 19 minus 14, which is 5. 24 minus 19 is 5. So we would say, yes, this is the arithmetic sequence, and the common difference is 5. Okay. It bothers me not to be able to write on here. Yeah, easy. We like this, right? You never want to say that, Greta, because then it gets hard. No, I'm just kidding. It's not too hard. Okay. For example, number 4, even though it's really small, I was trying to zoom out. 1/3, 2/3, 4/3, 8/3, 16/3. So the difference between the first two is 1. Oh, I can't even write. The difference between the first 2 terms is 1/3. The difference between the second 2 terms is 2/3, if I can talk. So 4 would be a big old no, right? It can occur in decimals. So like number 7, the difference between 3.7 and 4.3 is 0.6. The difference between 4.9 and 4.3 is 0.6. 5.5 and 4.9 is 0.6. So this would be yes. And the common difference would be 0.6, right? 0.6. So pretty easy. No big deal. Okay. So we like problems 1 through 8. We want them all to be 1 through 8, right? So it's going to get a little bit more tricky, but not that much more tricky. So yeah, we want them all to be like that. So we want to talk about the nth term of an arithmetic sequence. So basically, if you have an arithmetic sequence, you can use this formula to find any term. So I could ask you to find the third term in your sequence or the 100th term, and you could do that using this equation. Okay, so the equation is that a sub n, so any term, equals d times n plus c. Okay, all right, so that's just a bunch of new letters. A sub n equals d times n plus c. Okay, so d is, it's linked to up here. D stands for the common difference. Common difference, right? So for example, let's take number 1 here. If we wanted to write this as an equation, the common difference would be -2, right? So your equation would be -2 times some number n, because that's where it's varying, plus some constant C. So C, you can see, is right here. To find C, you take the first term, which in this case was 10, and you subtract it by the common difference, which was -2. So in this case, it's 12. So any term in this sequence can be defined by the equation, oh, my colors are messed up, a sub n equals -2n plus 12. Very exciting, right? All right, sorry, Connor just sent me a text. He's not be able to connect, but he's going to watch later. Okay. It's not too bad, right? I like all the chatting, Greta. All right. So, for example, if I wanted to find the 1, 2, 3, 4, fifth term, oh goodness, I can't even circle on my computer. If I wanted to find this fifth term right here, which is 2, I already know the answer. So I want a sub 5, that stands for my fifth term, okay, is -2 times 5 plus 12. So -2 times 5 is -10 plus 12, which is 2. So a sub 5, the fifth term, is 2, and voila, look it. There's my fifth term, 2. Ooh, ah, right? Oh, well, the next couple problems I kind of skipped forward, but that's all right. All right, so, yeah, pretty cool and easy. I agree. Let's look at these. So 9 through 16 is pretty easy. I kind of skipped a little forward. That's all right. Okay, so in 9 through 16, it says write the first 5 terms of the sequence, determine whether or not the sequence is arithmetic. If it is, find the common difference. Well, I kind of just gave you a spoiler alert because I told you what the equation of an arithmetic sequence is. So just based on how these equations look, right? Just based on how they look, I would tell you that number 13 and number 16 are probably arithmetic sequences, right? Because there's some version of a sub n equals the difference times n plus a constant. Okay. And I would venture to guess that number 11 and number 10 and number 14 are not arithmetic sequences just based on how they look, right? Because this has the n in a exponent, this has the n in an exponent, and this has the n in the denominator. So I'm going to guess that those are, and I'm looking at my notes and that's right. 10, 11, and 14 are not arithmetic sequences, and 13 and 16 are. If you wanted to find the first 5 terms of a sequence, basically you're just going to plug in and go for it, right? So for example, number 14, a sub n equals 2n minus 1. So if I wanted to find the first term, hey Sarah, it's 2 times 1 minus 1. Well, what is 2 to the 0 power? It's 1. Howdy. A sub 2, ask Greta, it's been easy so far. We're talking about arithmetic sequences. We got 2 minus 1, which is 2 to the 1 power, which is 2. A sub 3 is 2 to the 3 minus 1 power, which is 2 squared, which is 4. And so on. A sub 4 equals 2, 4 minus 1, so it's 2 to thirds, which is 8. So the sequence for number 14 would be 1, 2, 4, and 8, and so on. And that is not arithmetic, right? Because it doesn't have a common difference between each one. So that's pretty good. Hope you're having a good day, Sarah. It's a good day for some arithmetic sequences, right? Okay. So yeah, heck yeah. Always a good day for that. All right. So to find any term for an arithmetic sequence, remember the formula. Well, we just talked about the formula is a sub n equals the difference times n plus some constant. And the constant is found by taking a sub 1 minus the difference. Okay, so that's kind of our formula we want to keep in our mind. Number 17, well, 17 through 26, we want to find a formula for a sub n. Number 17 is awfully easy because they tell you that a sub 1 is 1 and the difference is 3. Okay, I know that the formula is a sub n equals the difference times n plus c. And I know that c equals a sub 1 minus d. Okay, so a sub 1 minus d is 1 minus 3, so c is going to be negative 2. So then I just write the formula. A sub n equals 3 times n minus 2. Voila, I have written a formula to find any term in this sequence. Very exciting, right? We like that. Yay for formulas. All right, let's get a little more complicated though, right? Just a little bit. I have been doing that all day, like drawing randomly. Let's look at number 26, because that looks fun. Yeah, 17, 19, 20, even 22 isn't that bad because you can tell what the common difference is, right? When you get to 23, 25, and 26, it's a little like, but it's not terrible. Okay. So we're going to have to think about number 26 a little bit differently. So we know that I can't type today. A sub 5 equals 190. And a sub 10 equals 115. Fantastic, right? We need to figure out, we have a couple of things we need to figure out. We have to find the difference and we have to figure out the constant. Okay. So what I'm going to do is I'm going to propose that we're going to find the difference first. And we're going to find the difference using a different method. Right? The difference we're going to look at, we are going from a sub 5, subtract a sub 10 minus a sub 5, right? That means that we are, in our sequence, we're moving 5 spots. So from the 10th term and way to so we're basically averaging the difference between the two. Okay. So we have terms that are apart. What we're going to do is we're going to say if I subtract 90 minus 115 and divide that by 10 minus 5, then I get that the difference is 75 divided by 5, or oh, I did that wrong. I put my numbers in wrong. Did you see what I did here? I just assumed the bigger number was bigger. Sorry. Go back 1 second, right? Or 5 seconds or whatever. All right, so a sub 10 is actually 115 and a sub 5 is 190 because this sequence is going down in value. So negative 75, that's right, over 5 equals negative 15. That's the difference. So that kind of makes sense. Like you're averaging the difference over 5 spots. It's kind of like finding the average. But because it should be the same exact difference, it shouldn't make a big deal. Okay. Now, but wait, there's more. All right, so now I know my equation is a sub n equals negative 15 times n plus c. Okay, and I need to figure out what c is. And c is a sub 1 minus d, but I don't really want to go backwards and figure out what the first term in my sequence is. So another option for finding that is that we know that, for example, when n equals 5, a sub n equals 190, right? So if I plug that in, 190, a sub 5 equals 190, which equals negative 15 times 5 plus some constant, right? Negative 15 times 5 is, oh goodness, I have it on my paper. I did a different one. Negative 75. That's what I thought it was. I shouldn't have known that. Okay, negative 75 plus c. So then I add 75 to both sides, and I get that c equals 265. So my formula would be, after all that, a sub n equals negative 15 n plus 265. So if you really wanted to double check that you did this right, you have another value, which is a sub 10. So if you put a sub 10 in here, which equals 115, if you put 10 in here, you should get 115. Okay, so if I do negative 150 plus 265, I end up with 115. So your equation works. Excuse me. Is that making sense? Greta, you got quiet. Still making sense? Cool. Sarah, you good? Cool. All right. Let's do some more. Okay. In exercise 27 through 34, write the first 5 terms of the arithmetic sequence. Use the table feature of a graphing utility to verify your results. Okay. So let's look at number 28 because that looks kind of ugh, right? So if I wanted to do number 28 and I wanted to write the first 5 terms of my sequence, the first one's done. It's 5, so that's good. The difference is negative 3. So one way that I could do this, since they give me the first term and the difference, is I can literally just subtract, or, the difference basically is equal to a sub 2 minus a sub 1. So if I know that if I'm trying to find a sub 2, the difference is equal to a sub 2 minus a sub 1, or a sub 2 equals the difference plus a sub 1, right? So I could just add negative 3/4 plus 5 together to get my next term, right? Unfortunately, we get to have the joy of a fraction for that. So it would be negative 3/4 plus 20/4, which would give me 17/4 for my next term. 17/4, right? And then I just keep going if I want to find my terms, right? The difference of the next one is going to be equal to a sub 3 minus a sub 2, or a sub 3 equals the difference plus that. So a sub 3 equals the difference plus a sub 2. So then I can keep going. I can say negative 3/4 plus 17/4 gives me 16, 15, 14, 14/4, or 7/2. So then my next term is 7/2. Dot, 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 dot. So that's one option. Another option would be you could say, oh, this is pretty easy. They tell me what the, I can easily kind of figure out what the formula would be based off of that, right? For 28, I probably would just go for it like this way. For 34, however, 34, I'm going to have to do something kind of similar to what we just did in that last problem, if I can make my computer do what I wanted to do today. Okay. So for 34, that's not what I was trying to do. Oh, goodness. I think I just zoomed. There we go. All right, there we go. So 34 is a sub 5 equals 16, and a sub 14 equals 38.5. 34 is a sub 5 equals 16, and a sub 14 equals 38.5. And I need to write the first 5 terms of my sequence. Okay. So what I'm going to do is I'm going to write my equation for the nth term of an arithmetic sequence, and then I'm going to use it to solve. Okay, so I'm going to go back to this a sub n equals the common difference times n plus c. And I'm going to figure out this equation for the sequence, and then I'm going to use that to solve the first 5 terms. Okay, so the difference for this is going to be a sub 14 minus a sub 5 divided by the spots between 14 and 5. Okay, so it'll be 38.5 minus 16 divided by 9, which I'm hoping is a nice number. So I found the difference to be that can't be right. Let's see. Let me calculate it. 38.5 minus 16 divided by 9 is, oh, that's why I did a different problem on my paper. Okay. Okay, it's 2.5. We're still good, right? So then if I want to find my equation, it's a sub n equals 2.5 times n plus c. I want to figure out what c is, so I'm going to use a sub 5. Okay. A sub 5 is 16, which equals 2.5 times 5. The n comes from this number here, plus c. So I have 16 minus 2.5 times 5. So c turns out to be 3.5. So my equation is then a sub n equals 2.5 n plus 3.5. All right. So now I actually have to find the first 5 terms of the sequence. So I can do that using Desmos. Okay. Good old Desmos. Desmos. So my equation was, and I don't think Desmos lets you make it fancy like this, a sub n. You can try it. Let's try it. A sub n does let you do it. I don't know if it's going to work on the other side. A sub n equals 2.5 n plus 3.5. Okay. And then what we want to do is we want to change this to a table. Let's see, we want to know if n equals 1. No, it doesn't like that a sub n thing. I got to figure that out. Maybe if we put this squiggly. No, it still doesn't like it. All right, well, I'm going to switch to y equals x because it's happier with that. Make this x and this y. Oh, it still doesn't like that. All right, let's start over. There we go. Okay, so the first thing that I want to do is I want to plug in when a equals 5, it equals 16, so that's good. And then when a equals 14, it should be 38.5. So when it equals 14, we should get 38.5. So that's good. That means we had our sequence there. So now I want to find the first 5 terms. Okay, so you're not going to actually start at a sub 0. You're going to start at a sub 1. So the first 5 terms would be 6, 8.5, 11, 13.5, and 16, if I typed right. Okay, so if I was going to write these down, I would just write them in this order, right? The first 5 terms of my sequence are 6, 8.5, 11, 13.5, and 16. Okay. All right. Any questions on that? Pretty good. Very exciting. Not too bad, right? Very exciting. That's what I was thinking. Okay. There is something that is the last few questions. I think you can do this pretty easily. It's given the first 2 terms, find the other term in the sequence. That's pretty easy because you can easily find the difference d and you have your a sum 1. So you just basically want to make that one should be easy. Okay, last little bit, actually, we're almost done. So this is not in your notes. I don't have a blue box for this. So I apologize. You have to make your own little blue box for this. So if we got sigma, he's coming back. If you want to find the sum so these are, so if you have 2n, right? That is 2 times n is an arithmetic sequence, right? Or 7 times n is an arithmetic sequence. If you want to find the sum of a finite arithmetic sequence, so again, this is on page 595 of your book if you want to get the box out. All right. So if you want to find the sum of a finite, so remember that's just a specific set, a finite arithmetic sequence. That's totally not spelled right. That has way too many extra letters. Okay. If you want to find the sum of an arithmetic sequence, you say that the sum S of S sub n equals the number of spots divided by 2 times A sub 1 plus A sub n. Okay, so kind of, it's not exactly like this, but kind of what you're doing is you're saying, I want to find the sum of all the numbers from 1, so number 68, what you're saying is that you want to find the sum of all the numbers from 1 to 100. So you're going to have 100 terms that you're adding up, okay? And the formula is it's 2 times n. So the first number is 2, and then 4, and then 6, and then dot, 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 all the way out to 100, where the last number is 200. So if you want to add all those numbers up, there's a formula to do it, which is the sum of the arithmetic sequence. So what it is I'm saying I want the sum of all the numbers to 100. All right. So I have 100 numbers divided by 2, and then I add together the first term plus the last term. Okay. And I get 50 times 202, which happens to be 10,100. So if I wanted to find the partial sum of this, it would be 10,100. So just a formula that helps you solve it. Okay. So then you can use your graphing tool to find the sum. It will do that for you. Here's Desmos. And under functions, miscellaneous, we can add up from 1 to 100, 2 times n. Voila. All right. And in number 76, you say you get to use the graphing utility to do that. So I think that's it today. I think you guys should be able to do that. It's pretty easy. If you run across anything that doesn't make sense, we can definitely go over it. But yeah, just try those out, and thanks for coming today. Bye. Bye, Sarah. Bye, Greta. Have a great day.